Tina slowly. We be working all day long to push us money. We ain't playing no games. Sabatavi, Gani.
Hello guys, we are still doing these questions. So now we are going to do number 2. So number 2, we are given 3 sine theta minus cos 2 theta plus 2 equal to 0. So guys, this is an equation. If you notice that we cannot change sine theta, but we can change cos 2 theta. Remember your double angles. So here in this case, guys, we need to choose the double angle that is in terms of sine only, which is in this case we are going to pick number 3. So I'm going to drop 3 sine theta minus from the formula, and then we open the brackets, guys. Then we change cos 2 theta to become 1 minus 2 sine squared theta. And then we close the brackets, plus 2 equals to 0. You don't forget this equation. Most of the learners, they forget the equal sign. If you forget an equal sign, so which means you are talking something else now. You are talking about expression. No, you are no longer talking about an equation. So we drop these 3 sine theta. Then we say negative 1 times times positive 1, you get negative 1. Then negative times the negative, then you get positive. Remember, we have 1 here, so which is positive 2 sine squared theta plus 2. So we can start with this one, guys. We have 2 sine squared theta, so plus 3 sine theta. So if we say negative 1 plus 2, we get positive 1. It's a sort of it is the same as your algebra, guys. If you want to make your life easy, you can say maybe let sine theta be equals to x. So now, guys, we have 2x squared plus 3x plus 1 equals to 0. So guys, if you don't know how to factorize this, you can go straight to quadratic. Quadratic will help you to get you the values, the solutions. So I'm going to factorize here, guys. So the factors of 2 is 2 and a 1. The factors of 1 is going to be 1 and a 1. So we can see that our c is positive, so the signs in the brackets must be the same. So in this case, it's going to be, we're going to take this sign of the middle term, is going to be positive and a positive. So therefore x is equal to negative 1 over 2, or x is equal to negative 1. But we were not solving for x, guys. We were solving for what? For theta. So now I'm going to say but x is equals to sine theta. So now we're gonna bring back a sine theta. So we will have here in this place sine theta is equal to negative 1 over 2, or sine theta equals to negative 1. Understand? So guys, we can see that the numerical value here is negative, so I'm going to get the reference angle. So after I got the reference angle, I need to go where sine is a negative. So I'm going to say here, I'm going to focus with this one first. I'm going to say a reference angle, which is equals to inverse of sine 1 over 2. So we know that, guys, inverse of sine 1 over 2 is 30. So we have 30 degrees here. Where do we find sine negative here? We find sine negative on quadrant 3 and 4. So we're gonna say 180 plus reference angle. So if I go to quadrant 3, guys, I will say we are solving for theta, so theta is equal to 180 plus my reference angle. In this case is what? Is 30. It's 30 degrees, then plus my period, which is 360 degrees, where k is the element of integers. So then we said 180 minus 30 will get a 210 as our solution, plus k to 360 degrees, where k is the element of integers. Then where do we find sine negative again? We find sine negative on which quadrant? Quadrant 4. So then I'm saying quad 4. Remember guys, we are still working with this negative half. After we are done, we are going to work with this negative 1. So I'm going to say theta. Remember in quadrant 4 we have a 360 minus the reference angle plus 360 degrees times k. So I'm going to say 360 minus my reference angle, in this case is 30, plus k to 360 degrees, where k is the element of integers, which is 360 minus 30, you will get 330 degrees times 360, where k is the element of integer. So we are done with this negative half, ne? Guys, we can put again up, you can put your reference angle here, I mean your periods. K is the element of integer. So we are done with this negative half, guys. We need to go to negative 1. So if we have sine theta equals to negative 1, I will find the reference angle again here. So you say a reference angle, which is inverse of sine, then you put 1, you ignore the sine. So plus the period. So inverse of 1, I think it's 90. So you have 90, guys. So then you need to go where you find a sine negative. So we all know that, guys, if our reference angle is 90 now, we know that sine is negative on which quadrant? A third and a fourth. So I'm going to quadrant 3 and the quadrant 4. So I'm going to say quadrant 3. Understand? So quadrant 3, I'm going to say theta is equals to 180 degrees plus my reference angle, in this case is 90, plus the period, which is k to 360 degrees, where k is the element of integers. So 180 plus 90, what do you get? 270. So plus your period. So then we go to quadrant number 4. Quadrant number 4, we have 360 minus your reference angle. So in this case, your reference angle, guys, is 90. So minus 90 degrees plus your period 360 degrees, where k is the element of integers. So if we say 360 minus 90, you get again 270 degrees plus k to 360 degrees, where k is the element of integers. Then you are done with this number 2 question. It was a little bit long, so we're gonna do number 3 here, guys. Number 3, what we have, we are given cos 2 theta plus 2 sine 2 theta minus 4 sine squared, right? Okay, let's copy the question down. Number 3, you can pause the video and try to attempt these questions on your own, guys, and see what you get. I know that you can do it. So we have this one, guys. Remember, cos 2 theta, guys, we can change it, but cos 2 theta have 3 personalities. So but sine 2 theta has 1 personality, which means whatever I do here, I will be restricted by this one. So if we manage to change this one to be 2, then we open the brackets, we change this one to be 2 sine 2 theta cos 2 theta minus, we have 4 here, sine squared theta equals to 0. So if we have this case, guys, can you see that, guys, this term is in terms of cos and the sine? So which means whatever identity I take here, the personality, I must take the one that has cos and the sine. So in this case, we're going to take option number 1, understand? So I'm going to change this one to become cos squared theta minus sine squared theta. So where you are going to get your first mark, guys, you're going to get your first mark here and here. So we can drop this one, cos squared theta minus sine squared theta. So positive 2 times 2, which is positive 4 sine theta cos theta minus 4 sine squared theta equals to 0. So guys, we see this one like terms. So I'm going to have here cos squared theta plus 4 sine theta cos theta, then negative 1 minus 4, we're going to get negative 5 sine squared theta equals to 0. So it's a matter of, guys, it's a matter of factorizing, guys. Yeah? So I'm going to open the brackets here. So the factors of cos, guys, is cos and a cos. The factors of sine is sine and sine. But we have 5. The factors of 5 is 5 and 1. So I'm going to have here 5 sine. Then I have sine on this side. Remember, the signs must be different here. Ne? The sign of the sign of the middle term is going to be taken by the big factor. So in this case, it's 5. So I'm going to put plus here and a minus here. So if we take this one and equate it to 0, I'm going to have cos minus sine theta equals to 0, or cos theta plus 5 sine theta equals to 0. We can see that, guys, if I transpose the sine to this side, I'm going to get cos is equals to sine theta. So what do I need to do now? I have to divide both sides by cos in order for me to get tan, because we cannot change cos, we cannot change sine. So, but if I divide both sides by cos, if you notice, guys, we are calculating the same thing here, but they just change the numbers. So cos over cos, it's 1. So sine over cos, we're going to get tan, then we're going to get 1. So we can find the general solution for this one, guys. Because it's tan and this numerical value is positive, we're going to get the reference angle, which is equals to inverse of tan, which is 1. You don't forget the period of tan. The period of tan, guys, we said is k to 180 degrees, where k is the element of integers. So inverse of tan 1, it's 45 degrees. Where do we find tan, guys, positive? We find tan positive on which quadrant? First quadrant and the third quadrant. So I'm going to say 180 plus my reference angle. Then I don't forget the period. So if I go to quadrant 3, I'm going to say theta is equals to 180 plus my reference angle, which is 45, plus k to 180 degrees, where k is the element of integers. So 180 plus 45, we get 225 degrees, plus k to 180 degrees, where k is the element of integers. Then we are done with this one, guys. We only have 2 solutions. When we work out this one and try to make a single trig ratio. So I'm gonna put this paper here, guys, here. Okay, let's put it here. I will try. So guys, we are focusing with this one now. So we have a cos theta plus 5 sine theta equals to 0. So we are going to do the same procedure. So I'm going to transpose the cos to that side. I'm going to be left here in 5 sine theta. So if we transpose positive cos to that side, it becomes negative cos theta. So what must I do in order for me to get tan? Because we cannot change cos, we cannot change sine. So I'm going to divide both sides by cos, and I divide by cos. But we don't need this coefficient, guys. I'm going to divide by 5 again, and a 5. So this cancel out. So this 5 cancel out. So sine over cos, we get tan theta. Now we have 1 here as your coefficient. So now we're left with negative 1 over 5. And the tan here, guys, is negative. So if it's negative, I have to go to quadrant 2 and 4. So, but the first thing I need to do is to get the reference angle. So if I want the reference angle, I will ignore the sign. Plus k to 180 degrees, where k is the element of integers. So what do you get as your reference angle? So inverse of tan 1 over 5. So we get 11,31 degrees. So then we go to the quadrants where the tan is negative. So we know that the tan is negative from quadrant 2 and the quadrant 4. So then if I say quadrant 2, So quadrant 2, we're gonna have theta is equals to 180 degrees minus your reference, which is 11,31 degrees, plus your period, which is k to 180 degrees, where k is the element of integers. So if we say 180 minus 11,31, we get 168,69 degrees plus k to 180 degrees, where k is the element of integers. Right, so we go to quadrant 4 again. So quadrant 4, guys, quadrant 4 says is 360 minus, so I'm going to say 360 degrees minus my reference angle. So in this case, my reference angle is this one, 11,31 degrees plus k to 180 degrees, where k is the element of integers. So if I say 360 minus 11,31, what do we get? We get 348,69 degrees plus k to 180 degrees, where k is the element of integers. So these are your solutions, guys, for this 45, 225 degrees, and also this one. So do you see that, guys? If you have the positive and the negative ratios, you are going to get how many solutions? 1, 2, 3, 4, 5. You're going to get 5 solutions. If you don't get the 5 solutions, yet you have a negative numerical value and a positive, just know that something went wrong. So in this equation, we are given 5 sine 2 theta minus cos 2 theta equals to 8 cos squared minus 3. So guys, we can see that this is a double angle, this is a double angle, this is an identity. So we can change this thing, we can change this thing, we can change also this identity. So the first thing that I'm going to do here is to change my double angle. So I'm going to have 5, this one is going to change to be 2 sine theta cos theta minus, then if I change this one, I'm going to take cos squared theta minus sine squared theta. Then on my left, on my right hand side, I'm still having 8 cos squared theta minus 3. So if I say 5 times 2, then I'm going to get 10 sine theta cos theta. So then we open the brackets here, negative times a positive, negative cos squared theta. After saying negative times a negative, then it's just a positive sine squared theta equals to 8 cos squared theta minus 3. Alright, so guys, can you see that if I transpose 8 cos squared theta to this side, the sign is going to change to be negative. So already on this side, we already have negative cos squared theta, which means I'm going to get a negative 9 cos squared theta. Then if we transpose negative 3 to that side, the sign is going to change to become positive. So guys, you can see that the sine squared theta is positive, so I'm going to push a sine squared positive forward. So if I push a sine squared theta forward, I'm going to have sine squared theta. Then remember, we have this thing, which is 10 sine theta cos theta. We said this one, negative cos squared minus 8 cos squared will give us negative 9 cos squared theta plus 3 equals to 0. Alright, so we need to factorize this because this is an equation, guys, but we cannot factorize this thing because it's not a trinomial and it's not a binomial. So we have this 3. Can you agree with me when I say 3 is the same as 3 into 1? Because 3 times 1 is the same as 3. But in this case, guys, we know that from trigonometry that 1, it's a square identity, which is equal to sine squared plus cos squared. So in this case, guys, because I want to have a sine squared and cos squared only here, I'm going to say sine squared theta plus 10 sine theta cos theta minus 9 cos squared theta. So I'm going to change this one to be plus 3 into, remember I said guys 3 is the same as 3 times into 1. So I'm going to say sine squared theta plus cos squared theta, then I close brackets, equals to 0. Understand? So then I drop this thing down again, sine squared theta plus 10 sine theta cos theta minus 9 cos squared theta. So we can see that guys, we're gonna open the brackets here, so which means 3 times sine theta is going to be 3 sine squared theta, then 3 times cos, then it's going to be 3 cos squared theta equals to 0. So far so good. So we can see the like terms guys, that here sine squared theta and the 3 cos squared theta, they are going to give us 4 sine squared theta. Then this is 10 sine theta cos theta, and we can see that guys, negative 9 cos squared theta plus 3 cos squared theta, they are going to give us what? Negative 6 cos squared theta equals to 0. So we can see that guys, the coefficients here, now we are happy because we have the trinomial, but the coefficient here, they are all even numbers. So we can reduce guys by dividing by the smallest factor, which is 2. We divide by 2. Now I'm going to be left here with 2 sine squared plus 5 sine theta cos theta minus 3 cos squared theta equals to 0. I hope guys you all follow my steps here. So now I will factorize guys. I open a 2 set of brackets. So here the factors of 2 guys is going to be 2 sine theta sine theta. The factors of 3 guys is 3 and 1. So but I'm going to put 3 on this side. So I'm going to have a 3 cos theta. Then on this side we have cos theta only. The sign in the brackets, they will not be the same because our c is negative and the middle term is positive. So the big factor is going to take the sign of the what? Of the middle term. So it's going to be positive here and the minus. Guys, I hope that you are able to factorize. So here I'm going to have 2 sine theta minus cos theta equals to 0, or sine theta plus 3 cos theta equals to 0. So we can see that guys are here. We can form tan. So I will transpose cos to this side. So I'll have 2 sine theta equals to cos theta. But in order for me to get tan, I need to form a quotient identity. So if I divide by cos, hope you understand. But I don't need also this 2. I will divide by 2 and also by 2 this side. So what we will get here, so this 2 is going to cancel this 2, and this cos is going to cancel this cos. Then I'll be left with tan theta, which is equals to 1 over 2. All right. Or what we will have here, we're going to have sine theta, same thing guys. We're going to transpose the cos to that side, minus 3 cos theta. Then I divide by cos both sides because I can see that I can form a quotient identity. So this is gonna cancel out. So sine over cos will still give us tan theta is equal to negative 3. Now we can find the angles using your quadrants. So now we are close to the final answer, guys. So what I'm going to do, guys, we said on the previous videos that on the previous questions also, we have to find a reference angle first. So I'm going to say here a reference angle for this one is equal to inverse of tan, which is 1/2, good people. So inverse of tan 1/2, what we'll get here. So we're gonna press our calculator to get the answer. So we're gonna press our calculator. So we know that inverse of tan 1/2 would give us 26,57 degrees. So guys, for this one, so I need to finish this one first, then I go to this one. So can you see that the numerical value here, guys, is positive? So we're gonna use our quadrant where tan is positive. We know that tan is positive on the first quadrant and the what, and the third quadrant. So guys, now it's simple. Since I have this as my reference angle, so I'm going to say here therefore theta is equal to 26,57 degrees. Remember, we said that the first quadrant is a reference angle plus the period. So this is the reference angle plus the period of tan plus k 180 degrees, where k is the element of integers. So where do we find again tan positive? We find tan here on the third quadrant. So I'm going to say, or then I say quadrant 3. Understand? So in quadrant 3, guys, I hope that you follow, guys, my steps. In quadrant 3, I'm going to say this is theta is equal to 180 plus your reference angle. So in this case, your reference angle is 26,57. So 26,57 degrees plus the period, which is 180 degrees, where k is the element of integers. Ne? So if we add 180 plus here, we're gonna get our theta to be equals to 206,57 degrees plus k to 180 degrees, where k is the element of integers. So we are done with this one because we're gonna have only two solutions if your numerical value is positive. Now we go to the next one. So in this case, guys, what do we have? We have the numerical value, which is negative. So which means I'm going to get the reference angle first and go where tan is negative. So I will put or again, then I say reference angle, guys. So it's going to be tan inverse. Remember, guys, we said that when we find inverse, we ignore the sign. So I'm going to put positive 3 here. So your reference angle in this case is going to be arc a tan positive 3, which is 71,57. So this is 71,57 degrees. Understand? So the first solution for this thing, guys, I'm going to continue here. So the first solution that I will say theta is equal to 71,57 degrees plus your reference, because the first option say quadrant 1 is your reference angle plus the period. So for tan is the reference angle plus the period of tan. I said that if your teacher uses 360, guys, it's fine. You can use 360 for your tan, but you need to do other things. So, but I always tell my learner to use 180. So I'm going to say plus k to 180 degrees, where k is the element of integers. So then we say again, go, where do we find a tan negative? We find tan negative on which quadrant? Quadrant 2, quadrant 4. So I'm going to find my solution in quadrant 2 and 4. So in quadrant 4 we have 180 minus the reference angle. So I'm going to say quadrant 2 here. I'm having theta is equal to 180 degrees minus my reference angle. So in this case, your reference angle was 71.57 71.57 degrees, and plus k to 180 degrees, where k is the element of integers. So if we say, guys, 180 degrees minus 71.5 is 57, what do we get? Remember, you are not allowed to write your answers in fractions. So we have 108. So it's 108.43 degrees plus k to 180 degrees, where k is the element of integers. So we go to which quadrant again, where tan is negative. On quadrant 4, we have 360 minus the reference angle plus k 180 degrees. So we say again quadrant 4. So we say theta is equals to 360 degrees minus 71, which is your reference angle, plus k to 180 degrees, where k, guys, is the element of integers. So what do we get if we say 360 minus 71.57? We get 288.43. 288.43 degrees plus k 180 degrees, where k is the element of integer. So then we are done with the solution. So this thing, guys, started here. We're given 5 sin 2 theta minus cos 2 theta is equal to 8 cos squared theta minus 3. So we did everything that we are supposed to do here. The tricky part was here, guys, where you were supposed to introduce your square identity. Then the rest is the same with the previous questions that we did in the previous videos. So, guys, thanks for watching. If you didn't subscribe, please don't forget to subscribe. So breathe in, breathe out. Maths is good. Thank you so much.